My name is Delasa Alijani Ashna and I'm a senior undergraduate student at Americabir University of Technology. I'm studying materials and metallurgy engineering and I'm a member of the research team in graphene and advanced materials laboratory, GAMlab. The subject of this lecture is the adsorption of heavy metal ions from industrial wastewater by 3D magnetic graphene. With the rapid development of world industry, a large amount of polluted wastewater is discharged into the environment. The industrial wastewater contain high amounts of heavy metal ions such as lead, mercury, and cadmium. These ions impose serious threats to the environment and human health due to their toxicity and non-degradability. Therefore, it is necessary to remove these ions from industrial wastewater. The industrial wastewater treatment not only eliminates the health and environmental hazards, but can also be considered as a secondary source for the recovery of heavy metals such as nickel and molybdenum. Different methods are used to remove these ions from industrial wastewater, such as chemical precipitation, adsorption, membrane filtration, and ion exchange. Adsorption is a simple method. It requires low initial investment and it's mainly dependent on the adsorbent's properties. Therefore, it is a cost-effective and promising method for this manner. Different carbonaceous adsorbents were used for the adsorption of heavy metal ions from aqueous solutions. Activated carbon is a conventional method for this manner and it is known to provide a high surface area for the adsorption. But using activated carbon has some drawbacks such as low adsorption rate and low adsorption capacity. They also have brittle structure which can cause into the release of pollutants into the solution. They also require reactivation process after each adsorption-desorption cycle. Therefore, it makes the process time-consuming and costly. 3D graphene-based adsorbents are new generation of carbonaceous adsorbents. They possess unique porous structure with high surface area and high pore volume. Therefore, they provide high adsorption rates and capacity, and they also don't require any reactivation process. Here, as a modified method, a 3D magnetic graphene is used for the removal of heavy metal ions from aqueous solutions. The 3D structure improves the adsorption process and the magnetic property of the adsorbent provides facile separation process which allows us to use the same approach in large scales. So now we want to remove the heavy metal ions from this aqueous solution. We want to use this graphene-based adsorbent for the removal process. After the adsorption process, we need to remove the adsorbent from the solution. For this manner, we use a magnet so the adsorbent will be adsorbed to the magnet. As you can see, the adsorbent was separated from the solution and now we can remove the solution from the vial and use the adsorbent for the desorption process. Thank you for your time and attention.